giving a question under shear force and bending moments now in my exam. Me seeing that diagram alone, I should know where I'm going to. In my head, I'll figure it out that this must be the shear force diagram. Certain. If I'm getting another thing aside from what I've pictured in my head, it means I'm doing rubbish. I'm wrong. You get? Then how do we know? Shear force and bending moment diagram. Shear force and bending moment diagram without calculation. Without calculation. This is your diagram. Sorry. This is your load. Then this is your shear force diagram. Then with this, we will now go back to question 1AI and 1AII. So from here, when you have your load, when you have something of this nature, when you have something like this, your shear force is still the same thing. When you have something like this, your shear force is still the same thing. When you have a line or a beam, let's say you have your line, your line is represented as a beam in this case. Let's say your line or a beam, you still have that line. When you have a UDL, you have a linear line. When you have, if this is your load, this will be the shear force diagram. If this is your load, this will be the shear force diagram. If this is a beam or a line, this will be the shear force diagram. If this is your load, this is a UDL, this will be the shear force diagram, a linear. Now, with this approach, let's draw shear force diagram of this loaded beam. Maybe you are getting me. With this, I want to draw shear force diagram without doing the calculation. It is when I did the calculation, I was able to plot this out. Now, say you've not done your calculation yet. How do you know the expected shear force diagram you are going to get? Now, let's apply. From there, I want to draw my shear force diagram. A reference line, which is my 0. On point A, relating, this is what I'm using to draw my shear force diagram now. Abi, this is my load in this case. What will be my shear force diagram? See that same stuff, right? Which is this. From A to C, what am I having? What the load? What type of load am I having? UDL. What do you have for UDL? Slant. Let me shift this to this place. This is where 0 is starting from. I'm having this. This is my shear force. For UDL, slant, right? For the UDL. On point C, what am I having again? Downward load. What is the shear force? Downward. I'm done with part C. From C to D, a UDL, right? What is shear force for UDL? Slant. On B, what type of load am I having again? Upward. What is shear force? Shade. Are you ready? Yes. Question 1AI. The question says that sketch the shear force and bending moment diagram for a simply supported beam of length. What's the length of the simply supported beam? Of span L meter, carry subjected to a central. Check now. Subjected to a central concentrated load P, right? Now let's sketch the diagram. Since I say it is a simply supported beam, since the question says it is a simply supported beam, what is simply supported beam? It is a type of beam whose both ends are supported, right? So let's say this is my beam. Call this A, call this B. It is a simply supported beam, meaning end A is supported while end B is supported. The span, what's the length from A to B? From the question, we are giving that from A to B is what? L meter, right? Let's call this place C. This beam, this simply supported beam, is subjected to a concentrated load at the center. When we say concentrated load, meaning a point load, and the intensity of this point load is P. So at this midpoint, this is P kilonewton. So you have to draw the shear force diagram and the bending moment diagram of this beam. How do you go about it? In this case now, assuming I'm doing my calculation, I'll be able to plot my shear force diagram and bending moment diagram. But in this case, the question just says that sketch. If you check that mark, just 2 marks. So you doing calculation and everything is like a waste. You won't be rewarded for that mark. So they don't want you to sketch. And how do you sketch? They are going to apply this analogy to it. You understand? Me having this simply supported beam. Since I'm working without graph, I have to bring out my graph. Abi, let's say this is my graph. For the shear force calculation, this is my reference line, which is 0. From here, I'm having, what is my type of load here? An upward load. What will the shear force? Still up. From A to C, what am I having? A beam or a line. And if the load is a beam, from A to C, it's still straight. Check. What do you have here? When your load is this, then you have your shear force to be this. So from A to C now, I'm having my load to be a beam. What will the shear force? Straight. Right? On getting to C, what type of load? Down. What will the shear force? Down. Check this table here. When you have your load to be a downward load, what will be the shear force? Still having the same. Okay, right down straight. This is a beam. From here, from A to C, you have a line, or you say your beam. Under this table here, we said when you have your beam or your line, this is your shear force value. Since you have from A to C to be the line, then this should be the shear force value. Sure you get? Then on getting to C, we have a downward load. Check here. What will be the shear force diagram of a downward load? Still that same load. And this is it here. Then from C to B, what do we have? A beam. That will still be what? Line. Then you have your upward force. Any question? Then shade. If you come to negative now, if you do your calculation, they didn't ask you to calculate. Since you know that shear force, you have positive and negative. It's something you can sense out that it will surely come down. Right, shear force diagram. It must be equal. The intensity here must be the same way. Only how you draw it, you are still correct. Just know that. So shear force diagram. That's shear force diagram. What will be bending moment diagram in this case? Bending moment will always start with 0 and end with 0. Since I know that bending moment will start with 0 and end with 0, this is my reference line. This is 0, this is 0, this is 0, abi? On this part, which is C, will bending moment be 0 there? No. Since I know that it is not 0, it's either positive or negative, but just like it is positive, it is positive.